Okay, so today we're going to talk about polynomials. So real quick, here's the definition of a polynomial. Okay? A polynomial, and what I did is I found a definition that was a little more student-friendly. Your book has a big formal definition. That's usually the one we go over. I think this one puts in a nutshell what a polynomial is, and I think this will help you better. So if you look in the book, yes, I know it doesn't match. I think this one explains things though a little better. It's an expression made with constants, variables, and exponents, which are combined using addition, subtraction, and multiplication, but not division. The exponents can only be 0, 1, 2, and 3, and it cannot have an infinite number of terms. Do we remember what the word infinite means? It goes on forever and ever and ever. So when we say an infinite number of terms, what it would do would have a plus dot 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 at the end, which means it goes on forever and ever. But that's what a polynomial is. An expression made with constants, variables, and exponents. They are combined using addition, subtraction, and multiplication, but not division. Okay. So keep that in mind. We're going to have some questions shortly. Okay, so here we go. Is this a polynomial? Yes or no? Here you go. I want you to go ahead and... Ooh, you two are on the ball. Is that a polynomial? Yes or no?
Dang it.
It is not a polynomial. So from that definition, could somebody tell me why it's not? It has a negative exponent. That's right. Remember it said the exponents can only be 0, 1, 2, and 3? This one has a negative 2 as your exponent. Okay, is this a polynomial? Yes or no? No.
Yes.
Why is it not a polynomial?
Because it's division.
It's got the division, 2 over x plus 2. Remember, you can't combine them using division. Is that a polynomial, yes or no? Yeah. Why not? I got that one.
There's a division.
The division again, 3 over x.
Oh.
Okay? Don't try to guess what I'm going to have because you never know. Is that a polynomial? Just when you think you have me figured out in terms of if I'm going to have all yeses or all nos or yes, no.
What's your phrasing does that on this test?
Yes. And the answer is yes. Okay, so first of all, we've got constants, variables, and exponents all combined using addition, subtraction, multiplication, no division. All the exponents are 0, 1, 2, or 3 or bigger, and it doesn't have an infinite number of terms. Okay, so now we're going to talk about what a degree and a leading coefficient are. And you're going to notice that the degrees are listed in red. The leading coefficients are listed in green. So I'll let you get that down, and then we'll talk about it.
Do we have to write all that down?
All right, so first of all, the degree of a polynomial is the value of the greatest exponent. Okay. The leading coefficient is the coefficient of the term with the highest degree. And so we have some examples down here. We have what's known as a constant, and that's just a number. That's what we call that polynomial, just a constant. Okay, it has a degree 0 because there's no variable, and the leading coefficient is 12. A linear polynomial is just a term written in terms of x. So we have 4x minus 9. It's a degree 1 because x is your highest power, it's x to the first. Your leading coefficient then is 4. Okay, quadratic, remember we looked at quadratics a ton, solving quadratics. That's a degree 2 because 2 is your highest power, and then 5 is your leading coefficient. And then we have a cubic function, which is something we haven't looked at, okay, but we will. And that's a degree 3, and the leading coefficient is 8. So hopefully you see how they relate. Now just a little tidbit, they don't always have to be in order. Okay? So it's not always the first term. It's just the term with the highest power. So they might not be written in order. So let's go ahead and look at this. What is the degree of this polynomial? So I want you to go ahead and tell me what the degree of that polynomial is. What is the degree? Looking for a number here. The degree is 3. Nice job. Okay, the reason why it's degree 3 is because we're looking right now at this term. Oops, a second, let me get my pen on. We're looking at this term right here, specifically that one. That's the highest power. Okay? So with that in mind, what's the leading coefficient of this polynomial? Okay, what is the leading coefficient of this polynomial?
Looking for a number or?
Leading coefficient. So remember back to that slide that we looked at when we discussed degree and leading coefficient? And the answer is 5. Nice job. The reason why 5 is, yeah, nice job, guys. Okay, the reason why it's 5 is because this is our term. And so all we're doing is looking at the coefficient with it. Okay, remember what I said, it doesn't always have to be written in order as well. What is the degree of this polynomial? Okay, so what is the degree of that polynomial right there? Nice job. Now I kind of tricked you there. Okay, the reason why I tricked you is because that's not in order. Okay, that's not where the highest power is first and all of them are next, so you actually have to look within the problem. And so, here we go. What is the leading coefficient of that polynomial? Let me get that out of the way. There we go. Sorry. What is the leading coefficient of that polynomial? 8. Nice job. Okay, good job. So we're getting the leading coefficient down and getting the degree kind of. Okay, so now, let's look at this one. It says state the degree and leading. So this is going to be like the instructions on today's assignment. State the degree and leading coefficient of the polynomial in one variable. If it is not a polynomial in one variable, explain why. So is that a polynomial in one variable?
No,
Why?
because there's a y.
There's a y, that's right. So this one you would say it's not a polynomial. And you could put because it has an x, because it has x and y. And last I counted, that was 2 variables. Okay, that's not one variable. And so that was it. So that's one of the things you need to be aware of. You need to read the instructions in each of the parts of your homework. And then the last few we're going to end on aren't going to take us a whole long time. It says find p of -4 and p of 2. Now notice our polynomial. P of x equals -2x squared plus x minus 3. What do you think you're going to do there?
Plug in -4 into or
Into where?
x.
X, good. So if I want to find p of -4, what I'm going to do is plug -4 wherever I see an x. Biggest mistake people make here, they mess up on the negative signs. Okay, so order of operations, I'm going to do powers first. -4 squared is what? 16, so I've got -2 times 16 plus -4 minus 3. What is -2 times 16? -32 plus -4 plus -4 minus 3 is what?
-20.
-39. So that is what P -4 is.
Oh, they're
Okay. I want you to do P2 right now. I want you to find for me what P of 2 is. When you get your answer, I want you to go ahead and type it into the expressions. Okay, so I want you to find P of 2. Shouldn't take you that long. Okay, so let's see what you had. Now this one isn't going to be coded since this was just a question on the fly. The answer actually is -9. Nice job for those of you that had -9. Okay, where you got that? If you have P of 2, what that means is that means -2 times 2 squared plus 2 minus 3. You know that -2 times 4 is going to be -8. Plus 2 minus 3 should give you -9. All right, so now that's not the only thing we're going to look at. We're going to look at something like this. Okay. Yeah. Find f of 3c minus 4 minus 5 times f of c if f of x equals x squared plus 2x minus 3. Yeah, this is going to be interesting. So the first thing we need to do is we need to find this right here. Okay. That's the first thing we need to do. So I'm going to come over here to f of x, and I want to find f of 3c minus 4. So what that states is wherever I see x, what do I put? 3c minus 4, right? So that means 3c minus 4 squared plus 2 times 3c minus 4 minus 3. So now I need to go through and calculate that. Now when you see 3c minus 4 squared, what that means is that means 3c minus 4 times 3c minus 4. So how do I do that? Remember what we do? FOIL. Yeah. So that's going to be a long one. So 3c minus 4 times 3c minus 4, which is 9c squared minus 12c minus 12c plus 16. And then we're going to get to this one right here, which is 6c minus 8, and then minus 3. So let's combine like terms. So f of 3c minus 4. Okay. F of 3c minus 4 will be 9c squared minus, so what do we have here? -12 and -12 is negative, plus 6 is -18c. And then I have 16 minus 8 minus 3, which is 5. Yep. I think it should be plus 5. There we go. So that's what's going to go right here. 9c squared minus 18c plus 5. Now what we need to do is we need to find what this is. It says 5 times f of c. So 5 times f of c. So first of all, what is f of c?
Is it not negative 5?
Oh, well, we could do the negative. That'd be fine. If you want to do -5 times f of c, there we go. Okay, so now let's do f of c. F of c will be c squared plus 2c minus 3. So all we're going to do is just put c in place of whatever x is. So now I've got -5 times c squared plus 2c minus 3. Okay. So what is -5 times that? -5c squared minus 10c plus 15. So now what I'm going to do is place that over here. So I've got -5c squared minus 10c plus 15. Final step will be to just add like terms together. So what does that come out to be? 4c squared minus 28c, good, plus 20. Nice job, and that is your answer. Okay, those are kind of longer problems. Looking at the clock for sake of time, I'm going to go ahead and we're just going to continue with this a little bit on Monday. Okay, we'll come back and finish those. What I need you to do right now is get started. I need you to go ahead and turn in your book to page 326. Okay, page 326. So on page 326, you are looking at 13 through 34. Okay. Okay, if you notice the first few say state the degree and leading coefficient in one variable. If it is not a polynomial in one variable, explain why. So if you're on page 326 right now, I want you to tell me, okay, I want you to tell me which one is not a polynomial in one variable. There's one right away.
13.
13, so you're done. You just say it's not a polynomial because there's an x and a y. So anyway, okay, for Monday.